so we're going to look at some series calculations to explain how these work. First thing, I think with series we understand the idea that resistance is found by adding up all the resistance. That makes sense to us, doesn't it? Pretty happy with that, we don't need any more. What this means is that current is constant throughout all series parts of a circuit. If we think back to our analogy, Kane, what was our analogy around? For current, what was our analogy around for a circuit? I just said it before, surrounding water pipes, correct? Water pipes where the battery's like the pump. The size of the pipes is the resistance. What is the amps in that case then, Leo? If in that analogy, water pipes, the pump is the voltage. The size of the pipe, the largest of the pipe is the resistance. So if you've got a small pipe, you've got a high resistance. What's inside of the pipe? That would be water. Oh, so that would be very good. So the current's our water. If we've got a hose, can you have more water entering the hose than leaving the hose? No. That's that law. The current around a circuit must be the same. You can't have more electrons entering this part of the circuit than leaving. So in this part of this circuit, it doesn't matter where I put my ammeter. Does that make sense? And this last one is just saying, well, I use up all my voltages as I go around my circuit. Cool? So if I had three 2 ohm resistors on a wire in series, and I had whatever volts, a third of the voltage would get used up in the first one, a third would get used up in the second, and a third would get used up in the third. If I added all those up, they would equal, let's say, the 12 volts that I started with. Cool? For parallel, we've got a more complicated resistance formula. This is the one that I would remember off by heart. Now if we think about our pipe scenario, the current has got two choices when it enters a parallel. It can take branch 1 or branch 2. This law just says the total water entering the pipes must be equal to the sum of all the different pipes' individual bits of water. Cool? So if you've got 10 litres entering here, or 10 amps entering here, say this one's got 6 amps, this one's got 4 amps, they're going to add back up to equal 10 at the end. Cool? And then on the last one, this was going through the fact that, ignore this resistor for this example, just ignore that, pretend that's wire. If I'm a little electron and I'm entering this wire, and that's not there, how many volts do I have just before I hit this? Have I got to hit anything after that? No. So I'm going to use all my voltage there, correct? Yeah. And what about the bottom one? If I go through the bottom branch, how many volts do I have here? How many do I have there? 0. So what I'm saying is I must use up all my voltage. And the voltage is the same across both branches. Because an electron can't go across branch 1, then come back and go across branch 2, can it? So it's going to use up all its voltage through that branch. They're the laws surrounding series and parallel circuits. The trick with combination circuits is knowing when and how to apply them. So the hardest part of this question is actually starting. The hardest part is knowing that I have to deal with this first. Why do I have to deal with this first? Well, we didn't deal with the parallel first last time, did we? We dealt with the series first. So what do I do with this first?
No resistance.
What was that, sorry?
No resistance.
I want to find my total resistance, correct? Yeah. So I need to treat this is the part that's making it complex. I need to treat that as I've got one resistor. So I need to replace these 2 lines and 2 wires and resistors with just one resistor. Now I can't actually do that, but I can find the equivalent resistance or the total resistance using that. Cool? So my first line I've just said, well, I'm just going to find out what the total resistance of that section is and treat it as though it is one resistor. Once I have RA, what am I going to do? Add it to my 2 ohms, and that will tell me my. Once I know my total resistance, what can I do? Find my total current. Once I have my total current, once I know my voltage, I know how much voltage is left, correct? And that will tell me the voltage through these two, which will help me find my current. Good luck.